Students, I hope I find you well. Welcome to yet another exciting edition of a chemistry lesson. Today we are going to focus on chemical reactions. We're going to look at how do we communicate to any other person that a chemistry reaction has occurred. We're going to look at how to convey information in a chemical equation, the symbols that we use for writing chemical equations, and also types of chemical reactions that we have. Anyway, to start off our lesson today, if a person were to ask you, what is a chemical reaction? Now, in any chemical reaction, you're trying to actually show what has happened, and you always start off with reactants. So all our chemical reactions, they will always start with reactants. And then we put an arrow to show that a chemical change has occurred, and at the end, we are going to have what we call products. So a chemical reaction is a statement that uses chemical symbols to show the identities and the relative amount of substances involved in a chemical reaction. But basically, in any chemical reaction, we have reactants on this side and we have products on that side. So our chemical reactions can be illustrated using what we call chemical equations. Okay, so we have chemical equations. And when we are looking at chemical equations, right, we are going to use only symbols, the symbols that we get from the periodic table. And some of the chemical formulae which we are going to write in our chemical equations, we actually derive them using methods that we studied in other topics. Okay, so chemical equations, we use only symbols. Okay, of course, we can have a simpler versions of chemical equations, which is a word equation, whereby we are going to be writing only words. Let me just illustrate what I mean by that. Okay, we can have magnesium burning in air and combining with oxygen, and then we are going to have magnesium oxide. Okay, this is a word equation because we are simply writing magnesium in full, oxygen in full, magnesium oxide. It's a word equation. These are our reactants. Okay, magnesium and oxygen, these are our reactants, and magnesium oxide is our product. Okay, so we are saying on this side we're going to have reactants, and on the other side we're going to have our products. But instead of writing magnesium in full, oxygen in full, we then go to the periodic table and then we come up with symbols. Okay, we are going to write Mg, okay, and we are going to write O2, okay, and the formula for magnesium oxide is MgO, like what we learned in another lesson. But this is not acceptable to people studying chemistry. We need to tell them the identities, because I said a chemical reaction is a statement that uses chemical symbols to show the identities and the relative amount of substances involved in a chemical reaction. So this is not acceptable. Why? Because you need to tell us what is the nature of the magnesium that you are using, what is the nature of oxygen, and what will be the nature or the state of matter for the magnesium oxide. And basically we have the following. Okay, you'll find S. Okay, I'll come back to this equation. I just want to define some symbols that we use in chemical reaction. We can have S standing for solid. We can have L standing for liquid. We can have G standing for gas. And then some of the substances will be AQ, meaning to say they have been dissolved in water. Okay, so we can have AQ. Okay, that's AQ. All right, so our magnesium, I have reacted magnesium ribbon in air. So this is S. Okay, the oxygen, we get it from the air, is G. And after the reaction, I'm going to get white ash, and the white ash is MgO, which is magnesium oxide. Okay, I have done the first stage. All right, so we also need to show the relative quantities that are present. Okay, in any chemical reaction, we need to obey the law of conservation of mass. Okay, you see here we have 2 atoms of oxygen, but there we have 1 atom of oxygen. Okay, right. So we need to actually put coefficients or numbers before these substances to ensure that the number of atoms on either side of the equation are equal. Okay, so to balance the number of oxygen, I put a coefficient 2 before MgO, so that I have 2 atoms of oxygen here and 2 atoms of oxygen there. But if I put a coefficient before MgO, I've also affected the Mg. So I have to go to this side of the equation and also put a 2 there. Now my equation is showing the quantities that were involved as reactants, because the equation is showing a balanced chemical reaction. This is very, very important when we are writing our chemical equation. We need to indicate the symbols, and we also need to balance the reaction. Okay, right. So we have done the first part, the first stage of this reaction. Let's move on to the second phase, or the second part of our lesson today. Okay, we need also to learn about these 2 arrows that we can have in a chemical reaction. As we proceed with chemistry, you are going to find out that in some chemical reaction you have 1 arrow. Okay, this means reaction proceeds in one direction. Okay, reaction proceeds in one direction. Okay, the reaction proceeds in one direction. In another lesson, I used this symbol. Okay, half arrow up, half arrow down. So we have an arrow going this way, and we have another arrow going in the opposite direction. What that means is this reaction is reversible. Okay, reaction is reversible. We have some chemical reactions which can go in either direction, either forward or backwards. So such a reaction, like the one I illustrated before, had 1 arrow pointing in one direction, which means that reaction is unidirectional. It goes in one direction. But if there is a half arrow up and half arrow down, it means the reaction goes in either way. It's a reversible reaction. Now, in chemistry, we need to classify our chemical reactions. Just like what we have in biology, we have the animal kingdom. We classify them so that it's easier to study them. The same applies to chemistry. Our chemical reactions can be classified so that we are in a position to study them easily. Okay? So today we're going to look at 4 classes of chemical reactions. Okay? 4 classes of chemical reactions. We're going to look at synthesis, combustion, single replacement, and double replacement. Okay? The names, okay, will be in a position to help us to classify them easily. And I'm also going to be giving you some examples. All right? So, to start off our classification, let's focus on synthesis. Okay? I suppose you still remember synthesis in the word photosynthesis. Synthesis means to put together. Okay? A plus B, and we end up with AB. Okay? We had separate elements A and B as our reactants, and now we have the product AB. What have we done here? We have carried out a synthesis reaction, such as in the case of photosynthesis. We have certain reactants that are being combined in the presence of light. That's why we have photo, which means light, synthesis, meaning together. And we are putting together certain elements in the presence of sunlight. That's why we call it photosynthesis. So we have A, B separate, and we have B now, which is our product. Okay, let's just have a look at an example here. Okay, we can have the formation of methane, for instance. Okay, formation of methane. Formation of methane, we can use carbon. Our carbon can be graphite, so it's carbon solid, and then we have hydrogen gas, and then we have our methane gas. Okay, that's synthesis. Separate elements, and then we end up with methane. Okay, again, we have 2 atoms of hydrogen there, 4 atoms of hydrogen this side. So our equation is not balanced. Okay, we put a coefficient there, 2 times 2, 4 hydrogens, and we now have 4 here and we have 4 there. And our equation is now okay. That's a synthesis reaction. Okay, let's move on and we look at combustion. Okay, combustion. If you want to simplify the word combustion, you can simply say burning. Okay, so when we are burning substances, we use the gas oxygen from the air, such as burning metals. Okay, so we can say my metal A is going to be combined with oxygen, and then I form the metallic oxide. Okay, right? So I have 2 oxygen there, 1 oxygen there. So what do we do here, students? 2 here, 1 here. I put a coefficient 2 there to make sure that I have similar number of O. The coefficient is also affecting A, so I go to this side and I put a 2 there. And my equation, or my just symbolic equation here, is now balanced. Okay, let's look at a very simple example. Okay, suppose I'm burning sodium, okay, in A, right? Sodium, all right? Sodium is a solid, oxygen is a gas, and I'm going to form, okay, sodium oxide, which could be a solid, all right? So we have a scenario here where we have 2 sodiums here and 1 sodium there. So what we do, we have to put a 2 here, okay, to ensure that our sodiums are the same, okay? But we have not solved our reaction, okay? We have 2 oxygen there and we have 1 oxygen here. So what we do, okay? We have 2 oxygen here, okay? And we have 2 and 2 oxygen now. But if you now check, we have 2 oxygen there and now there's a 2 there. So we have to have 2 times 2, and it means I have to go back here and correct, okay? And put a 4, okay? So that my reaction is now okay, right? So this is what happens when you're writing your equations in the exam. Sometimes you have to put coefficients and sometimes you have to rub them so that the equation appears balanced, okay? So you check again, 4 sodium here, 2 times 2, 4 sodium here, oxygen there 2, oxygen there 2. My atoms of either element on both sides are equal. So that equation is balanced. So whenever you have an element combining with oxygen, we regard that as a combustion. Okay. It could also be some form of synthesis because you have separate elements here and you have 1. Okay. But we could call this one a special type of synthesis because we are involving oxygen, and we classify this further by saying yes, it's synthesis, but it's a special type of synthesis, and as a result we call it combustion. We have done the first 2. Let's just look at the last 2 before we end the session. Okay, right. So the next one, we call it single replacement. Okay, single replacement. And we are going to look at why we are using the word single. Okay, obviously from single, we're going to move on to double replacement. Okay, so let's look at A, B plus Y. And then we have A, Y plus B. Now, if you follow through what's happening there, B has been replaced by Y, okay? and we have only replaced B in this equation. And as a result, we can call this one a single replacement, okay, reaction. Some textbooks, indeed, a number of references may even say single displacement. That's also acceptable, okay? For instance, we can have this reaction, potassium iodide, okay, which is an aqueous solution, okay? We can have our chlorine also dissolved in water. We have chlorine aqueous, okay? And at the end of the day, we'll have potassium chloride aqueous, and then we have iodine, which is a purple solution, okay? Right, let's look at what has happened here, all right? You can see that your Cl has actually displaced, or it has replaced our iodine, okay? So there's some form of bit of balancing the equation, which we must do. For instance, you see here, there's 2 iodine there, 1 iodine here, okay? So we put a 2 there, okay, to balance off our iodine, and the coefficient is affecting K, all right? Meaning to say 2 potassium atoms, we still have 1 there, okay? So we put a 2 there to also balance our potassiums, okay? So let's check throughout. Potassiums, 2 atoms, chlorine, 2 atoms, because this coefficient is also affecting chlorine, so our chlorine are sorted. Even our iodine, 2 atoms there, 2 atoms. So that equation is balanced. Why single replacement? Because we have had our chlorine replacing iodine in that case, so that becomes a single replacement, okay? We can move on to double, okay, replacement, double replacement. Let's look at an equation that we can do in qualitative analysis. Maybe we want to identify the presence of copper, the copper ion, okay? So we can use sodium hydroxide aqueous, okay? And then sodium hydroxide is going to react with copper 2 chloride, which is also aqueous. And then if you do that, you are going to form sodium chloride aqueous, and then you are going to form copper hydroxide. Normally, this one will appear as a precipitate. This one will appear as your precipitate, and normally we describe it as blue precipitate, okay? It will appear as a precipitate. That's why I'm putting S there, okay? Right, so the OH in brackets, there is a 2 outside. I have to come to this side of the equation to balance my OH, and I put a 2 in front of NaOH, okay? I was balancing OH. In the process, I affected Na. So I have to come here and also put a 2, okay? Now, if you can check throughout the equation to check whether your atoms are balanced, 2 sodium atoms, 2 sodium atoms, 2 chlorine atoms, 2 chlorine atoms, okay? And our copper is also balanced, our hydroxyl also balanced. So we are sorted, okay? Right, so we have looked at 4 types of chemical reactions today. We have dealt with synthesis, we have dealt with combustion, we have dealt with single replacement, we have dealt with double replacement. This is how we classify our chemical reaction. Our double replacement reaction, which we have looked at today, is also special in the sense that it can be precipitation, okay? These are our products, and if you are to look at them when they are inside the container, you are going to have layers, okay? Sodium chloride aqueous will be at the top with the liquid, and our copper hydroxide will form a precipitate at the bottom of the test tube. And we can actually separate them using filtration, because the sodium chloride is aqueous. It actually goes through the filter paper, and the copper hydroxide will be trapped by the filter paper, and then we can dry it, okay, slowly, and we can then get our copper hydroxide. This was our session today. I hope you've managed to learn chemical reactions as well as their types and basics of balancing equation, as well as the symbols that we use when we are writing chemical equation. Thank you. Please remember to subscribe and to like this video as well as to share with your friends so that they can also benefit from what we are covering in this session. Thank you.